Hello, my name is Teresa Stack. I'm an assistant professor for Montana Tech at the University of Montana. And this learning unit is called Lifting Assessment Tools. And we'll learn how to use different evaluation techniques for manual material handling or lifting type tasks. So our objectives will be to recognize the limitations and the benefits of different lifting assessment tools, practice using the tools, and then hopefully learn how you can use them as a way to put solutions in place. So there are three main lifting assessment tools. We'll cover the ACGIH TLV for lifting and the MIL-STd in this module, and the NIOSH lifting equation will be covered later in a separate module. So some of the advantages here for the MIL-STd, the reason why we do cover this tool is because it's one of the only ones that can be used for multi-person lifting as well as carrying and one-handed lifting. So neither the NIOSH lifting equation or the ACGIH lifting tables can be used for those particular lifting operations if you find them. The ACGIH TLV for lifting, I like it because it can be updated every year depending on what the committee chooses to do. And probably the most popular one would be the NIOSH lifting equation. So the Department of Defense Design Criteria Standard for Human Engineering is MIL-STd, MIL-STd 1472G. And G was updated in 2013, so it's relatively new. It establishes general human engineering criteria, principles, and practices for design and development of military systems, equipment, and facilities. And although it was originally established for the design and development of military systems, we can absolutely apply it to our industrial processes and evaluate existing tasks as well. Its purpose is to present criteria so that people can maximize their performance while minimizing the strain on the workforce, and try to standardize some of the ways in which controls and displays and workstations are established to make sure they're within the limitations and the capabilities of the personnel. So the MIL-STd maximum weight design limits is what the table is called, and it's part of a rather large military standard. It looks at a couple of different lifting parameters. So the first step in using the MIL-STd would be to determine your population, whether you have a male-only population or you have a mixed population with males and females. So if we're doing relatively a low lift, your males can lift 87 pounds from the floor and place it on a surface no greater than 3 feet from the floor. You can also lift from 3 feet and place it on the floor. Kind of goes both ways. Your female population can lift 44 pounds. The reason why there's a difference between these two numbers is that the MIL-STd recognizes that there is a difference in strength capabilities for your male versus your female workers. Excuse me, so it takes that into account by having a lower value there. And then you can see the higher we lift, so if we lift up to 5 feet, your males can lift 56 pounds and your females can lift 37 pounds. So if we know our population, we may be able to use this column. If we don't, then we'll have to use this column to be most conservative for everybody that's lifting. So what the MIL-STd also does is it says that these one-person values can be safely doubled for 2 people if 2 people are doing a lift. So you're doing some team lifting. And that's where these italic figures come into account. Oh, there's a mistake here. I lost a number. It must have fell off the page. I'll look that up while I'm going on here. So you can see that 2 males can safely lift 174 pounds and place it on a surface no greater than 3 feet from the ground, and that 2 females can safely lift 88 pounds no higher than 3 feet from the ground. 2 males can safely lift 112 pounds and place it on a surface no greater than 3 feet above the ground, 5 feet above the ground. And then your 2 females, 7 and 7 is 14 can safely lift 74 pounds and place it on a surface no greater than 5 feet above the ground. So the higher the lift, the lower the weight, and when we start to combine the people we're lifting with. So if you have two females can safely lift 88 pounds, or if you have one female and one male, they can safely lift 88 pounds or 74 pounds, depending on the height of the lift. So the other thing that the MIL standard does is that it recognizes that this is a low frequency. For this to be safe, it has to be done at a low frequency. And your low frequency is only 20 lifts per hour. So if you have more than 20 lifts per hour, if you're lifting an object that's greater than 18 by 18 by 12, if you're doing multi-person lifting, if the object isn't balanced, if there's obstacles in the way, then going deeper into the MIL standard allows you to adjust some of these factors based on the task. So when you have two people lifting, so one person can safely lift 44 pounds. This is at 36 inches, our mixed population. One person. Two people can safely lift 88 pounds. Well, how much can 3 or 4 or 5 people lift if we have our mixed population? Well, our MIL standard shows us that, or tells us that, where there are 3 or more people doing a lift simultaneously, not more than 75% of that one person value may be added for each additional lifter. So basically what we're doing is we're taking this 44 pounds and we're reducing it by 25%, right? And then we'll just add these numbers together. And we're going to do an example so you'll be able to see that. If you have an object that's lifted more than 1 lift in 5 minutes or 20 lifts in your 8-hour period, then we need to reduce that maximum weight by as much as 50% or 33%, depending on the weight in which we're going to do our lifting factors. And then if the object is greater than 18 by 18 by 12, we need to reduce that maximum weight even further, because it's assuming that if you have a person, excuse my drawing, who's holding an object within 12 inches for their body, that the load is close. The deeper the object, the further that the weight is held away from the body, and the higher the load on the lower back. So let's look at an example here of our sailors doing a weight handling task. So you have the MIL standard, and you have, oops, you have the MIL standard, and you have the total travel distance. So we know we're in this criteria. We have 2 males, so we recognize we're in this criteria. And we see that they can safely lift 174 pounds. Since the generator and the paint sprayer are less than 174 pounds, we say that we believe this task is safe for these males. They're only doing it 4 times a day. Now if we make a switch and I tried to help one of these males do the job, and we're still within our category B, but we moved over here because we have a male and a female. I'm helping this guy do the lifting task, right? And so we can safely lift 88 pounds. The generator and the paint sprayer, they don't stay the same. Would we say that this task is safe? I find it questionable because these numbers are pretty close together. And we know that our females are a little bit weaker than our male population, about 30%. But you see, gentlemen, we make it up in wit, and therefore we don't have to be as strong as you. And the 88 pounds is pretty close to the 82 pounds. The closer these numbers are together, the higher the likelihood that somebody's likely to be injured. So let's say we have another task. We have 4 workers who are lifting a large half-sided box. It has good handholds on it. The lift is brought to a surface no more than 36 inches above the ground. It's a mixed population. What's the maximum amount of weight that this team can lift? Well, our first step is to determine what the one-person safe lifting limit is. So we have a mixed population, no greater than 36 inches. We know that one person can safely lift 88 pounds. Oops, 2 people can safely lift 88 pounds, and 1 person can safely lift 44 pounds. So we need these numbers. Now we need to figure out what the other 2 people can safely lift. Well, we don't need to make any adjustments to the 88-pound figure or the 44-pound figure, and we're going to need both of these. But we don't need to make any adjustments because the frequency is low. It's not greater than 20 lifts per day. There's no obstacles in the way, and the weight is evenly distributed. So the way we do our calculation is the MIL-STd tells us that we may take no more than 75% of the one-person weight limit for every person over 2. So we have 88 pounds for 2 lifters, and we have 33 pounds for the remaining 2 lifters, being 66 pounds. And when we take our 88 and we add it to our 66, we find out that our 4-person lifting team can safely lift 144 pounds. And this is because we had our mixed population. If we just went to an entirely male population, you see that these 2 figures would change. So that's how you do your adjustments. First, you find the 1-person lifting limit. Then you make any adjustments to it for frequency and duration. Then you add in your additional people that are doing the lift over 2. Okay, so that was all for the MIL-STd. Now we're moving on to the American Conference of Governmental Industrial Hygienists, and we're looking at the values that they use when they're recommending limits for lifting. And as you know, the ACGIH is a professional society. It's not a government organization. And they develop consensus standards, which most all industrial hygienists, as well as ergonomists and safety professionals, follow. And they're listed as either biological exposure indices or TLVs. And the lifting index is a TLV. Of course, it's a threshold. It's a line in the sand, and you're assuming that if you're below that line, all will be well. So this just comes right from the ACGIH guide if you haven't read it. They recognize that work-related musculoskeletal disorders are important occupational health problems. The term musculoskeletal disorder refers to chronic muscle, tendon, and nerve disorders caused by repetitive exertions, rapid motions, high forces, contact stress, extreme postures, vibration, or low temperatures. I would also add you kind of have ligaments in there as well, and because we have musculoskeletal, we can have problems with bone or cartilage or spinal discs. They also state that some transient discomfort is normal, but if the discomfort persists from day to day or interferes with your after or your work activities, that you're probably going to have an unfavorable outcome, which means you'll develop a work-related musculoskeletal disorder. The TLV does not provide protection for people with pre-existing conditions such as arthritis, or if they are obese, have had acute trauma, are pregnant, or if their recreational activities are very similar to the activities that they're doing in their everyday job. They also state specifically that engineering controls are the recommended control factor for eliminating the likelihood that somebody's going to be injured. Although we can't completely eliminate the risk, we sure could reduce the risk some way. So a threshold limit value, a TLV, is a recommended workplace lifting condition which it is believed that nearly all workers can be exposed repeatedly day after day without developing a work-related low back or shoulder disorder associated with the repetitive lifting task. And the ACGIH looks at four specific task factors. The horizontal distance being how far is the object held away from the person's body. The vertical distance, which is the position of the hands at the start of the lift as well as the position of the hands at the end of the lift. The frequency of lifting, whether it's 2 or more hours per day or less than 2 hours per day. And the duration, that's the duration of lifting, as well as the frequency of lifting. The frequency of lifting would be how many lifts are we doing per day, or per minute, or per hour. So horizontal distance, vertical distance, duration, and frequency. So the directions tell us to first read the directions. And then we really need the task duration and the lifting frequency to choose the right table. And this is probably the most challenging part of using the ACGIH TLV for lifting. It's because there's 3 different tables and use different ones depending on the combination of duration and frequency. So it'd probably be a good point to kind of have those tables there so that you can take a look at them while we're going through this. So the duration, when you look at the duration, you're looking at, are people lifting for more than 2 hours a day? Or are they lifting for less than or equal to 2 hours a day? So the task duration is basically based around 2. And this is the cumulative dose for lifting. How much are they lifting throughout their entire day? If we have 2 30-minute segments, then they're only lifting for an hour per day. If we have 4 30-minute segments, then they're lifting for 2 hours a day. 5 would make it greater than 2 hours a day. And the lifting frequency, sometimes that's something that we can get directly off production data. Other times we have to estimate it. So one way that you can estimate it is how many widgets are you lifting in a day? Well, I work on 50 tires, ma'am. And how many times do you lift it? Well, I lift it off the truck, then I put it on the bead breaker, then I take it off and I put it on the tire balancer, and then I take it off and I put it back up on the shelf again, so I guess I'm lifting it 4 times a day. Well, that must mean that you're doing 200 lifts per day. And then I can break that down to 200, to how many lifts somebody's doing in an hour or in a minute if I need to, based on the table. So we need the task duration, and we need the lifting frequency, and then we can find out which lifting table to use. So what I'm doing here is I'm just comparing table 1, which is your low frequency table, to table 3, which is your high frequency table. And so you can see table 1, you can safely lift 31 pounds from the floor to the middle of the shins, 40 pounds from the middle of the shins to the bottom of the knuckles, 70 pounds within this power zone, and 35 pounds once I get above shoulder height. And this is at a low frequency. It's like 12 lifts over an 8-hour period. And we'll take a look at the table. This is your high frequency table. And because we're lifting at a high frequency, it means that our body doesn't have a chance to recover. And since our body doesn't have a chance to recover, we need to bring these weight values down significantly so we don't put any undue pressure on the lower back. So here I have no safe lifting when I'm down below the middle of my shins. 19 pounds from the middle of the shins to the bottom of the knuckles. 30 pounds in the power zone, 25 pounds up above the shoulder height. And you can also see when looking at these tables, whether you're looking at one or two, that the further the object is held away from the body, the lower the weight. Because we know the further the object is away from the body, the higher the force is on the lower back. So you're taking a look at Table 1. And first we need to determine, are we working less than or equal to 2 hours a day or more than 2 hours a day? Once we know that, then we take a look at the frequency that's associated with that duration. So here on our low frequency table, if I'm lifting more than 2 hours a day, then I'm only allowed to do 12 lifts per hour or 96 lifts throughout the entire day. If I'm lifting less than 2 hours a day, my body has a chance to heal. So here I'm allowed to do up to 60 lifts in an hour or 120 lifts in that 2-hour period, because it's a 2-hour exposure. So now we have Table 1, Table 2, and Table 3. Table 3 is for high frequency, long duration lifting. See, there's no less than 2 hours a day here. So the worker is working more than 2 hours a day, doing between 30 and 360 lifts per hour. That's between 240 and 2,800 lifts per day. This is an aerobic event. Ooh, this is a hard one. If we're lifting more than 2 hours a day, but our lifts are between 60 and 360 lifts per hour, we're able to use, if we're lifting more than 2 hours a day and our lifts are between 12 and 30 lifts per hour, then we're able to lift between 96 and 240 lifts per day. And then here we have more than 2 hours a day. We're only able to lift 12 lifts per hour. See where the 12s come into contact with each other. This is 96 lifts in an 8-hour period. So step 1, is it 2 or more? Or 2 or less? If it's less, we need to look at these ones. If it's more, we'd be looking here. Based on our frequency and our duration, we choose the correct table. Step 5 is we need to determine our vertical zone. And our vertical zone is set up in a number of different references. What I like about the ACGIH TLV is it's based on the stature of the individual. So it doesn't matter whether you're 5 feet tall or 6 foot tall, the distance from the floor to the middle of your shins is considered your low lifting zone. Then you have the middle of the shins to the bottom of the knuckles to the below shoulder height. That's your third lifting zone. That's your power zone. Oops, it would be bottom of the knuckles to below the shoulders. This is your power zone. Then you have from 3 inches below your shoulders, which is basically shoulder height, to 12 inches above your shoulders, and to 12 inches above your shoulders is the top of your lifting zone. That's the top of your reach limit. So floor to middle of the shins to bottom of the knuckles to bottom of the shoulders, bottom of the shoulders to 12 inches above the head. These are your 4 different lifting zones. So step 6 is to determine the horizontal zone. And the horizontal zone is just basically how far the object is held away from the body. So if we're able to get the object really close to the body, that's our close zone within 12 inches. And that's usually when the elbow's bent. and right in at the side of the body so it's not extended forward. This will be your 12 inches. Where your 24 inches, your arm is usually on an angle because you're getting further away from your body. 12 to 24 is your intermediate. And then your far zone, the person would actually be leaning forward here. They'd be quite unhappy because they'd have a lot of pressure on their lower back, and then they'd turn into a rabbit. And the far zone would be between 25 and 32 inches from the body. So we have both the horizontal zone and the vertical zone that we take a look at. So the easiest way to measure this is from the L5-S1 vertebrae to look at how far the object is held away from the worker's hands. But you can also measure it from the midpoint of the worker's stance to the center of their hands. This is the way the ACGIH TLV likes you to do it. NIOSH likes you to do that as well. So you look at the position of the center of the person's stance and the distance that is to the center of their hands. But it is really hard to calculate, and usually this person is kind of making up her stance there. It's really hard to get the middle of your stance away from where your L5-S1 vertebrae comes in contact, where the L5-S1 vertebrae is. So we determined our frequency and our duration, we picked the right table, we did our horizontal distance, our vertical distance, and then we used that as a starting point. Now the TLV says that if the load is placed in a controlled fashion, then we have to calculate the TLV. I'm so sorry. If the load is placed down in a controlled fashion, then we need to recalculate the TLV for both the start and the stop of the lift. So basically you'd make two different calculations and see which one is more conservative, which one produces the lowest number. I do this all the time anyways, just to make sure that I'm not missing something in how I'm interpreting the results. So then we use that as a starting point, and ACGIH recommends that we reduce the number found on the table by some percentage if we're lifting at high frequencies, more than 360 lifts per hour, if we're lifting longer than 8 hours per day, if we're twisting more than 30 degrees when we're lifting, if we're doing one-handed lifting, if we're in constrained body postures. Should never be lifting more than 10 pounds in a seated position anyways. We learned that in workstation design. If you have poor coupling, so you can't hold on to the object really well, has a shifting center of gravity like liquids, if you're on unstable footing, or during or immediately after exposure to whole body vibration. So what I don't like about the ACGIH TLV is that if I came up and said that a worker can safely lift 70 pounds, but I found out that they were twisting more than 30 degrees while they were lifting, it tells me that I need to reduce this number by some percentage, but it doesn't tell me by how much. So there you have to use your professional judgment when you're looking at how much. If you want to get more specific with something like twisting or coupling, you would ultimately go and use NIOSH. So let's take a look at our lifting task. And choose which table you would use. So you can pause this to find which table you would use based on the duration and the frequency. So based on the frequency and the duration, you should have chose table number 3. This is a high frequency task, 60 lifts per hour. She's lifting for more than 3 hours per day. She's lifting 35 pounds unground, 45 pounds unground, 35 pounds ground. Could be much more weight than that. Those were the averages that the buckets weighed. And so when you're looking at that task, you can see that here it's much harder for her to do the lift than it is up in this zone, because she's able to use her momentum or keep things at elbow height. So we could evaluate this task on each and every level, but since there's not a 45 or a 35 on table number 3, we know that this task isn't safe. But can you now use the tables as a solution guide? And that is, and look at the different tables. Look at the frequency and the duration and the weight that this person's lifting and the body posture she's in. Is there one of those tables that will help you figure out what kind of solutions you can put into place so that she goes home happy at the end of the day and without an increased risk of developing a back injury? So if you took a look at the tables, one thing you can see that if we did worker rotation and if we reduce the task to just 2 hours a day, then we can go ahead and use table number 2, and now the task becomes safe. Right? So just worker rotation, getting her out of that 3 hours per day down to 2. Another administrative control would be smaller, lighter bins. We have less weight, but then your frequency and your duration are going to go up. So you can only use the top 2 racks. That would be another administrative control. It would still be unsafe, but it would be safer than it was, potentially reducing the probability of injury. Maybe, maybe not. Some engineering controls, if there was a grinder which double grinds the meat so she didn't have to feed it back through 2 or 3 times, this would reduce the frequency by half, right? So we'd have a lower frequency. We'd still be on table number, at which we'd have to look at that by reducing the frequency. I think that would bring us down to table number 2 as well. And then finally, you can have a machine, which would ultimately be the engineering solution, to feed either both the ground and the unground, or just the unground meat back up into the top of the grinder, so she didn't have to actually lift it all. So I hope that you enjoy somewhat of the recording. I'll get better over time. This is the first time I use this particular media device, but I thought it would be really useful for you to be able to see and go through this together, because we're starting to go through things that are slightly more complicated than just looking at pictures. I hope you have a splendid day. Thank you.